Hey everyone, my name is Anthony Oshima, and today I will be talking about Miranda, a lazy, purely functional programming language. What is Miranda? Miranda is a functional programming language designed for creating concise, elegant, and efficient code. Developed in the late 1980s at University of Kent, Miranda has inspired many modern functional languages like Haskell. So why Miranda? Miranda is known for its simplicity and expressiveness, making it an excellent choice for developers seeking clean and maintainable code. It encourages functional programming principles, emphasizing immutability, high-order functions, and declarative programming. Some background history. In the late 1980s, researchers were exploring novel approaches to programming language design and implementation. David Turner, the primary designer of Miranda, aimed to create a language that was more expressive and concise than existing languages. Functional programming movement. Miranda emerged during a period when there was a growing interest in functional programming paradigms. Functional programming languages emphasize the use of functions as first-class citizens, immutability, and declarative programming styles. Turner's work was influenced by earlier functional languages like Lisp and ML, but aimed to create a language with a strong focus on simplicity and ease of use. So let's talk about some data types. Miranda supports various data types, including integers, characters, and booleans. Miranda has a statically typed system, meaning that variable types are determined at compile time rather than runtime. Here we have age, which is equal to 25, our integer, a pi value, which is equal to 3.14, our floating number, first letter, which is our character A, and is true, which is our boolean. List data types. Miranda has a powerful list data type for handling sequences of elements. Lists can be manipulated using various functions. Here we have an example that I pulled from the text I use, programming with Miranda. We have weekdays, a list of strings representing the weekdays, Monday, Tuesday, Wednesday, Thursday, Friday. And then we have days, a new list formed by concatenating the weekdays list with the list Saturday, Sunday. This list, this results in a list containing all 7 days of the week. Tuple data type. Tuples allow grouping of values of different types. Tuples are similar to lists, but are usually used when you want to combine a fixed number of items, and each item might have a different type. In many programming languages, including Miranda, tuples are immutable, meaning their values cannot be changed after creation. Here we have an example. Date equals 20 May 1999. Data is a tuple containing 3 elements. The first element is an integer 20, and then second element is May, which is a string, and the third element is our integer 1999. Same thing with the person. Person, but it's the same thing except the last element would be a boolean. Functions. In Miranda, functions are a fundamental concept used for defining computations and manipulating data. Since the language is purely functional, Miranda has a mathematical nature to it. Let's talk about polymorphic functions. Miranda supports parametric polymorphism, allowing functions to work with values of any type. Here we have an example, myFST, and then in the tuple we have 3, 4. myFST would be just indicating extracting the first element in the tuple. We have on the second example we have myFST 3 and then another element A and true. Then again, it's extracting the first element, which is 3, and then the last line would be extracting my SND, which would be my second. It extracts the second element in the tuple, which is A true. We have another example here on the right side which is dupe. This simply just duplicates whatever's in the tuple with its original value, and then it duplicates and it sends it to the result. Function composition. Here we have two functions, add 2 and multiply by 3. Add 2 just simply adds 2, and then multiply by 3 simply multiplies by 3. So we have a composition which creates a new function that adds 2 and multiplies 3 just by calling back the two other functions previous. We have an example here, example usage on the bottom. Add 2 and multiply by 3, and then we have an input of 4, and then that would result in 14. Curing. Miranda supports curing, a technique where a function with multiple arguments is transformed into a sequence of functions, each taking a single argument. Curing is beneficial for several reasons. Partial application. You can partially apply a function by providing only a subset of its arguments. This can be useful for creating specialized or more reusable functions. Function composition. Curing aligns well with function composition, allowing you to easily combine and create new functions. Flexibility. Curing provides a flexible way to work with functions, making it easier to reason about and manipulate them. Here we have an example at the bottom which has add curried. It's a function that takes an integer as its first argument, and then it returns a function. The return function then takes another integer and then produces an integer result. So we have example usage. We have add curried 3 and then 4. Add curried function is partially applied with the argument 3, and then this partial application then results in a new function, and then essentially a function that adds 3 to its argument. So once the add curried 3 is evaluated, it should be a lambda expression, which is lambda y, which is it goes into 3 plus y. So then we would just have that lambda expression, and then we would then fill in the y with the remaining 4, which is a result in 3 plus 4, which is 7. Now let's talk about higher order functions. Higher order functions are functions that can take other functions as arguments and or return functions as results. This allows for a more expressive and flexible programming style. So here we have apply twice, which takes a function f and a value x and applies f twice to x. For example, square n is equal to n times n. Now that would be a function, and we're going to apply that function with another function. So apply twice would apply to square, and then it would apply to 3. First square would be squared. 3 would be squared once, and then that results in 9. And then being squared a second time by apply twice would result in 81. And then on the right hand side we have our an example that I used that I took out from the text, which has a couple of higher order functions. Recursion. Recursion is a key concept in functional programming. So here we have an example. We have a simple recursion. This line, the first line, declares a function named factorial that takes an integer as an argument and returns an integer. The first line inside the function is a base case. It says that when a factorial is called with an argument 0, which is a factorial 0, the result is 1. And the second line is the recursive case, It says that for any other value of n, the result is n multiplied by the result of calling factorial with the argument n minus 1. This recursive call continues until it reaches the base case factorial 0, and then it just stops the whole recursion. Let's talk about lazy evaluation. Lazy evaluation is a programming language feature where expressions are not evaluated until their values are needed. Rather than computing the value of an expression eagerly, the evaluation is deferred until the result is required for a computation. Miranda being a lazy evaluate language, this offers several advantages. So here are some of the advantages. Efficiency improvement. Lazy evaluation can lead to more efficient programs by avoiding unnecessary computations. Expressions are only evaluated when their results are needed, reducing unnecessary work and potentially saving computational resources. Infinite data structures. Lazy evaluation enables the creation of and manipulation of infinite data structures. Since values are computed on high demand, you can work with structures like infinite lists without causing the program to hang or run out of memory. Modularity and abstraction. Lazy evaluation promotes modularity and abstraction by allowing the separation of the definition of data and the computation over the data. This separation allows for more modular and composable code. Support for higher order functions. Lazy evaluation is particularly well suited for higher order functions, where functions can accept other functions as arguments, and then it allows for the creation of more abstract and reusable code. Impact on program efficiency. This example illustrates how lazy evaluation can improve efficiency. We have an infinite list of numbers, and we have first three, which only takes the first three elements using take three natural numbers. So Miranda only generates the necessary elements 1, 2, and 3, and then it stops. It doesn't attempt to generate the entire list. It only takes the 3 numbers that you asked for. Real-world applications. Miranda is a functional programming language that gained popularity in the 1980s and 1990s. While it was influential in the development of functional programming concepts, it didn't achieve widespread adoption, and its usage in real-world applications has been limited. However, some projects and applications have been developed using Miranda. Research and education. Miranda has been used in academic settings for teaching and research in functional programming concepts. Its simplicity and expressive syntax made it a suitable choice for illustrating functional programming principles. Prototyping. Miranda was sometimes used for rapid prototyping of algorithms and software components due to its concise and expressive nature. It allowed developers to quickly test and experiment with functional programming ideas. Mathematical and symbolic computations. The functional programming paradigm is well suited for mathematical and symbolic computations. Some projects might have used Miranda for tasks involving complex mathematical calculations. Functional programming research. Miranda has been used in research projects related to functional programming. Its design and features have contributed to the exploration and advancement of ideas in the functional programming paradigm. Challenges and limitations. Limited industry adoption. Miranda has not gained widespread adoption in the industry. Its use has been limited compared to other programming languages, and the majority of developers may not encounter Miranda in their professional work. Outdated technology. Miranda was developed in the late 1980s, and its technology may be considered outdated by modern standards. The language lacks certain features, and libraries are now common in contemporary programming languages. Limited libraries and ecosystem. The lack of a vibrant ecosystem and extensive libraries for Miranda can be a drawback. Developers often choose rich ecosystems that offer a wide range of tools and libraries for various tasks. And finally, competition with Haskell. While Miranda influenced Haskell has become more prominent in functional programming landscape. The competition with Haskell might overshadow Miranda's prevalence, as many developers prefer Haskell for its richer features and community support. In conclusion, Miranda is a gem in the world of programming languages. Its simplicity, expressiveness, and functional programming principles make it a language worth exploring. Whether you're a seasoned developer or a programming enthusiast, diving into Miranda can be a rewarding experience.